about IP addresses because we already started IP address, MAC address. So why should we repeat that point again? So IP addresses, we have two versions already I told. So IP address is a logical address, and IP address we have two versions, IPv4 and IPv6. So here it is, some differences will go. IPv4 is a 32-bit, whereas IPv6 is a 64-bit. Sorry, again I made a mistake. 128. So I never do mistakes, mainly in this thing. Okay, maybe typo mistakes or maybe spelling mistakes can be there. So mind. Okay, so IPv4 is a 32-bit size. Okay, size. That's one IPv4 you written in a binary format. It is a 32-bit in a number. If you write IPv6, you take one IPv6 and convert into binary. It is 128 in a binary number. Okay, so total IPv4s means from starting of IPv4 to IPv6, the total IPv4 addresses are 2 to the power of 32. It is 4.3 billion IP addresses. 4.3 billion IP addresses. Whereas IPv6 2 to the power of 128, it is 3.4 billion. Actually, there is a number like a undecillion. Okay, that is a number called a undecillion. Okay, you take a calculator. So okay, in this one you put a there is added trigonometry functions. Same thing on this, no difference. 2 to the power of 32. This is the number wise. So around 4 billion is around 4 billion 294,967,296. Okay, so that much number it is. Guys, here it is small point, like you know already, but sometimes just for fun also people ask this question in interviews. So what is million? What is billion? Okay, million means 10 lakhs, billion means 100 crores. 100 crores. So how much it is for IPv6? 2 to the power of 128. So this is a much bigger. It is around 3.4 into 10 to the power of 38. The power of 38 means we take 34. After 34, put a 37 zeros. 37 zeros. So that is the bigger instance. So compared to IPv4, IPv6 is very bigger. Okay, so IPv4 is a very limited. And IPv4, we are all using IPv4 based communication only, not a IPv6 communication. Of course, some countries, complete entire country, they use IPv6 like Germany, Japan kind of stuff. Okay, and certain private networks, for example, you take Geo use IPv6 communication. Okay, because entire worldwide, so not every server or every routers not supporting IPv6, they are supporting IPv4 only. So not only in India, so outside like big countries like US, Australia, UK, they're all older systems, still they are supporting only IPv4, not IPv6. So that's why still we are using IPv4. Maybe in future, so complete globally we use IPv6. because IPv6 also mandatory, guys, because number of devices also increasing every day. For example, I'm using a mobile, currently one mobile only, and then I have a tab and I have a laptop like that. So multiple devices, type of devices, and IoT came into market. Then lot of devices need to connect it to the network. So we need more IP addresses. IPv6, IPv4 still we are managing, but we need in future IPv6 only. Direct public access also will increases with the IPv6. IPv4, we'll write IPv4 in a decimal format. Whereas IPv6, we write in a hexadecimal format. Running of IPv4 different, IPv6 is different, guys. If you don't understand IPv4, still we can understand IPv6. You understand complete IPv4 structure, maybe you may not understand IPv6. Maybe may not be understand IPv6. Complete idea is different. Okay, so it is a decimal format, that is hexadecimal format. Example of IPv4, if you see 192.168.10.20, some random IP address pick up just for example purpose how it is look like. In IPv6 there is an example like a anything. Actually, I will put it in a sequence manner. So now I'm putting random manner. Okay. Better cap letters so we can visibility is good. This is not a alpha numeric kind of stuff, guys. Hexadecimal means every number, it is a number, it has a value. E is also having a value. Yeah, you must know what it is. I'm not going to explain that one. So this is the size of IPv6. So first of all, we need 8 blocks. So this is the 4 blocks. This is 3 blocks only. So 1, 2, 3, 4, 5, 6, 7. So one more block is required. Okay, this is the IPv6. So see how much bigger it is, like that. Yeah, very small IPv6 is also there. Size is like by the writing of IPv6 also changes depends upon the IPv6 address also. Just it is just for our understanding, guys. If you see IPv4, so first of all I will tell about IPv4 and then we'll come back to IPv6. And IPv4, see this is the parts. 4 parts are divided. IPv4 divided into 4 parts. Okay, so it is divided into 4 parts. Okay, so means 32 by 4. How much it is? 8. Means each part is 8 bits. Each part is 8 bits, which we call it as an octet. Each part we call it as an octet. So we have a 4 octets. We have 4 octets separated by dot. By dot. Some people tell point, guys. It's not a point. We should spell like a dot. 192.168.10.20. Okay. So this is your IPv4 part. Okay, first one. Okay, separated by dot. first part we call it as a first octet. Second part we call it as a second octet. Third part we call it as a third octet. Fourth part we call it as a fourth octet. So one more point I missed. Here it is. Each octet is saying the octet means 8 bits, right? Octet means 8 bit. 8 bits are there. Each octet is 8 bits. So 2 to the power of 8 means it's a 256. Total 256 numbers in the one octet. So it is exactly say 0 to 255. The numbers are 0 to 255. For example, 7 is there, 7 numbers. Total from starting to now it is 7 numbers, means 0 to 6. Okay, 0, 1, 2, 3, 4, 5, 6 up to 255. You count it, it is totally 256 numbers you will get it. So each octet is, the size of octet is 0 to 255. So maximum size of each octet is 255 only. So it means this octet size is, maximum size is 255. Okay, this is 255. So total number of octets are 4. Yes, some people write these octets and stuff in the easiest purpose. They write in this W.X.Y.Z. Okay, so if you go to certain textbooks, certain videos, some people classes, so instead of telling first octet, second octet, third octet, fourth octet, so they will tell W.X.Y.Z. That is also correct because it is make it more easy to say identification kind of stuff. Okay, so but the original pattern is first one is first octet, second one is the second octet, third octet, fourth octet, like that one. The start of IP address, when you start with an IP address, so here it is, the first IP address, that's IPv4 range, total range is from 0.0.0.2 255.255.255.255. This is the total IP address range. Total IP address range. You know how it is start? The starting address is this one 0.0.0.0. That is the start of IPv4 address. The next address is 0.0.0.1, 0.0.0.2. Like it will keep goes and reaches 0.0.254. And next one is 0.0.255. I need a one small space. A space is not there. W.X.Y.Z. This is total range of IP addresses, and this is the sequence just I am trying to give. You know what happened after you reach 0.0.0.255, so you'll go to 0.1.0. Okay, 0.0.1.0. 1.1, 0.0.1.2. It keep goes 0.0.1.254, 0.0.1.255. Now what happened after that? It becomes 0.0.2.0. Okay, again 0.0.2.1. It keep goes like this. Once you reach 0.0.255.254, then you'll go to 0.255.255. This is the last one. Keep repeats, guys, like a 2.255, 2.255, then 3.0, 3.1, 3.2, and 3.255, then it is 4.0. It keep goes, and once we are completed up to here, okay, so if you write all these things in a paper, so if you and count it, okay, I cannot type everything, okay, sorry. 0.1.0.1. So it is also same thing, it keep goes like that only, okay, it keep goes like that only. So it will reaches finally 0.255.255.255 will reach it. And you will get a 1.0.1.0, 1.0.0.1. Okay, same, it keep goes. It was like that. So finally reach 255, 255, 255, 255 kind of stuff. Finally reach 255, 255 kind of stuff. So this is the range. This is the range, 0 dot series, total range. Okay. Okay. This is the total IP address ranges. So not now. So started class. So now free. So it's not free at break time. So it's free now. Okay. Now this is it. So here it is. This is our total IP addresses. Guys, understand what I am writing?
Yes, sir.
These IP addresses, the total IPv4 addresses divided into 5 classes. Class A, Class B, Class C, Class D, Class E. Totally 5 classes. Guys, there is a binary number is also there. Okay, so binary kind of stuff is also there. Okay. The division based on first octet. Okay, so we take only first octet to understand what class it is. So we take your class A, the first one is 0, right? This is the 0. So we take that 0 first. And we are taking range, means this is the first one. So first bit is not touching, the MSB constant. The first bit is same. Remaining bit becomes once. Okay. Remaining bit once. Then class B, what the next one? టైం పడుతుంది పవన్ పైన పడేస్తాం సో 6 ఆపేస్తానులేండి కంటిన్యూ చేసి హాఫ్ అన్ అవర్ ఆపేస్తాను okay. So here it is one next this is a second B class B is a second one means 2 bits. Okay, if you cannot remember guys, I'm telling, if you cannot remember how to write this binary kind of stuff, not at all a bother, because we are not taking seriously class addresses, subnet mask and all kind of stuff. We should know the ranges, that's it, but compulsory ranges are important. Okay, 1100 and this is constant, first three bits same, remaining become ones. Class C is next bit, C, class E, all are ones. Okay, we'll try to ranges now. So in a normal format, this is important, 0 to 128. If you go to some textbook, it will shows 1 to 127. There is a reason why 1 to 127 is sorry, 1 to 126. That's a one. Don't do these mistakes. I said no, I don't do these mistakes because it's in my hand, it's in my brain kind of stuff. Okay, so 1 to 191, 198 to 191. Okay, 192 to 223, 224 to 239, 240 to 255. So this is total ranges. So important is class A range, class B range, class C range. These ranges are very important. And I said in certain textbooks we write only 1 to 126 instead of 0 to 127. There is a reason. So here it is, we can't assign to any host IP addresses to any host. Any host means any computer or any device. Host is a actual good word actually. Any device or any computer. Okay, like this. 0.0.0 is an IP address. It is a reserved IP address. So certain reasons. So like for example, static routing, maybe default routing, not static. In static, default routing. In routing concepts, just for example, DHCP client use this 0.0.06 for a DORA process. So like that, there are so many reasons it is there, and 0, this is entire series cannot assign. Can't assign to any adapter. It does not mean it is invalid. It is used by certain services. Okay. Next, 127.0.0.1. This is very carefully listen, guys. This is also reserved IP address for a local host or a loopback ID. Okay. This is used for a self-testing. What is self-testing? Go to command prompt. I want to test my TCP IP is working or not. TCP IP service is working in my PC or not. So I want to do a self-test. 127.0.0.1. Okay. So I'm getting reply means my TCP IP in my laptop, it is working. Self-testing, not to test others. So ping is a command, use it to test other, like I can able to communicate that device or not. This is self-testing. Can I communicate it to my device? The communication path is there. Those services, firewalls, everything is clear for that purpose only. Okay. So it is a local host or loopback address. Self-testing. Okay. Same system. Service access. Means in my system, I install some application I want to access through web access. But I want to connect it to my service. For example, I am giving an example. I installed Oracle database in my example. New one is 21C in my system. Now I want to access from my system only. Then I use localhost 27 0.0.1 from SQL plus it's a client application. From SQL client application. If I want to access from different PC, the system, whatever the system, laptop, you say to different system. In network, so yeah, we needed to connect with the network. Have to use my system IP address. If you don't get it, no problem. Okay, but try to understand, guys. I have a system, my PC having application, my PC having client. I want to access. Then I use this localhost IP address. But I have another system. I want to access from other system to this system. Then I need to access with my system IP address. Okay, my system. Instead of A and B, I given I kind of stuff. Okay, so A system, B system, I will tell, but I told you like this. And of course, 127 dot. This series not using. Okay. Next one is, guys, can't assign class D and class also. Can't use class D, class C ranges also. Why? Because of class C is called a research and development. R&D means it's a reserved. It's reserved for a R&D purpose, and it is a multicasting IP address. It is a multicasting. Next, as the multicast IP address used by certain services. Again, it is also reserved for certain services. Example, services are protocols. Example, boot P. Deploy OS or applications. So when we use this is to deploy, means install operating system or applications to multiple devices at a time through network. At a time through network. Second, uh, exchange of routing tables used by protocol EI, G, RP, OS, TF, and RAP version 2. It's a boot prism and protocol. Okay, so these are the protocols we use directly. We don't assign to any device. So next, I think everybody out of mind. So because I keep telling, no one is asking any questions. It's a unicast addresses we use. If we can assign to devices. Okay. So it is a unicast addresses, class A, class B, and class C. Of course, not all IP addresses. These IP addresses you can use it. Guys are okay up to now?
Yes, sir.
Total lot of information. So we'll back to IPv6 guys, IPv4, IPv6 kind of stuff. IPv6 128, 2 to the power of 128 is 3.4 into 10 to the power of 38. It is represented in hexadecimal format, example of IPv6. It represented in hexadecimal format means one hexa number is equal to 4 bits. So you divide 128 by 4, so you'll get a 32. Okay, 32 hexa numbers you will get it. 32 hexa numbers you'll get it. Okay. For a 4, each 4 hexa numbers as one block. One block. For each 4, each each 4 hexa numbers as a one block and separated by colon. Each 4 of hexadecimal number as a block and separated by colon. So how many blocks you will get it? 8 blocks. Okay, total. So we have 8 blocks. Separated by colon. That is separated by 8 blocks. Okay, so this is the point. See, you can see 8 blocks, and of course there is a lot of information is there. So we'll try to give that information. So guys, we have a classes, but here it is don't have any classes. So we have a global unicast address. It is a kind of public IP address. Okay, it is actually represent like this. Okay, /3 type. Okay, it means the range is, if you see any IP address, it is showing like this 20023FF range, means starting part. If you see this part like this 20023FF, the starting block is 20023FF. Any number between 20023FFF, it is a global unicast address. It's a public IP address to communicate in the internet. It is assigned by IP address. Next type is link local. Link local. Link local IPv6 address is starting is FE80::. This is the range. /64 represent like a subnet mask prefix type. We don't use subnet mask here. We use a prefix. IPv6 don't use subnet mask. We use a prefix. Link local IP address. Yeah, we have a history about link local IP address. Okay. It is generated by our system using MAC address of that NIC. So which NIC it is? It is based on that NIC's MAC address. That is very easy. And using NIC's MAC address works in LAN, within a LAN. It works within your LAN, means within your network, local network. Okay, single LAN, one LAN. Okay, so it not required any DHCP, DNS kind. Guys, you have a private IP, private and we can use the private and public IP addresses here. Private and public IP, link local, private and multicast address. Range is also there. Okay, so that's we are not using that word. FC. I have a beautiful picture for that one, so I lost some picture. Private and multicast IP addresses also there in a IPv6. One start point is I'm trying to say we don't use no subnet mask. No subnet mask. We don't use subnet mask. We use only prefix. Prefix represented in slash notation. We use a prefix to separate network and host. Separate network and host. So subnet mask part I will tell in IP addresses part. Okay, definitely. Yeah, I know that's a little complex. Um, and there is some more points I forget here. Let's just look at here. Okay, so what is local host or a loopback in IPv4? It is a 127.0.0.1, but in IPv6 also there is a address called a ::1. It is a ::1, and yes, we give a yeah, we can add those things here. Separation. You know 0.0.0 in IPv4. IPv4. Just for data I'm giving, guys, so don't worry. In IPv6, just ::. Okay, 1 second. Okay. Okay, sorry. Yeah, so this is what we have done. Just before continue, guys, before I am going to continue, so I'm going to review short review about IPv4. Okay, so what are you learned? Just I'm giving here. What is an IP address? Logical address, and we have IPv4, IPv6 in the IP addresses. 32-bit IPv4, 128 IPv6. 2 to the power of 32, it is 4.3 billion IP addresses. IPv6, 2 to the power of 128, it is 3.4 into 10 to the power of 38. IPv4 represented in decimal format, IPv6 represented in hexadecimal format. Okay, in IPv4 we divide IPv4 into different classes: class A, class B, class C, class D, class E, kind of stuff. Total IP addresses, the range is 0.0.0 to 255.255.255. This entire range is we divide into 5 classes. And coming to the IPv6, guys, IPv6 is actually division not based on the numbering system. It is a different ranges are there. So global unicast, link local IP address, private IP addresses, multicast IP addresses, and anycast IP addresses are divided like that. Okay. Of course, there is a anycast range is also there. There is anycast means all RFs. All RFs means 32 Fs are there in Anycast. So maybe yes, it's a bit separated. In IPv4, guys, we have a subnet concept is there. In IPv6, we don't have a subnet concept. We use a prefix to separate a network and host portions. The network and host portion concept I will explain. So separate along with this IPv4 only. Only network and host portion. What is network? What is host? Okay. So. But it is complete. Just that. Link localhost IP address is 127.0.0.1 in IPv4 and IPv6. It is a ::1. In IPv4, it is 0.0.0 is represented in IPv4. Same thing it is represented in IPv6. One more example I will try to show you guys. See, I am pinging to 10-15 minutes. Close చేస్తాను 10-15 minutes అయిపోయింది 10-15 minutes రేపు లేదు ఎల్లుండే. So I'm trying to communicate to my local host with IPv4. So I'm telling -4 means try to communicate with the localhost IP 127. Same, I want to communicate with IPv6 ping -6 you have to give. So it is ::1. Okay, so ::1 means it is a localhost address in IPv6. Okay, guys, once again, classes: class A, class B, class C. That's it. That's enough. Okay, we need a first 3 classes only because we use these 3 classes for our use these 3 classes because there are a Unicast IP addresses. Their ranges only have written. Okay, guys, IP addresses actually 2 parts. One is host part, another one is a network part. If you are using a class A IP address, so then first part is a network part, remaining is a host parts. Class B, first 2 are a network part, remaining is a host part. Class C, first 3 are network part, remaining is a host part. Okay, so based on that, we have a default subnet mask also there. You know what is the class A default subnet mask? Like this. Of course, I will tell that one also. Just I'm trying to waste times up also. Okay, so what is this host part and network part? So look at here, guys. I'm writing a class A IP address. Okay, so first of all, 10. This is a class A IP address. How I know it is a class A IP address? Have you seen the? This is also okay, no problem. The first octet. First, look at the first octet. Is it? Yeah. Okay. I got some meeting part. Okay, so I have to leave. It is a class A. How I know it is a class A? Look at the first octet only. Any IP address, first look at the first octet, then check with the range. Check with the range, then we know it is a which class it is. And what is their network portion, guys? Network portion is 101. Remaining here host portion. The host portion is okay 112333. This is the network portion. That is a host portion. Okay, identification of network and host portions. Next, 139.23.112. Okay, 223. Anything. Which class it is? Check the first octet.
B. Class B.
Class B. Very good. Okay. What is the network portion? So this is the network portion. This is the network portion. Like this. This is the network portion. So we'll highlight. This is the host portion. For example, I have a 200.10.123. Okay, or maybe 127. What we have to see first? First octet.
Class.
Okay, so then we got a class. Based on the class, what is the network portion? First 3 are a network portion. So this is my network portion is 200.10.123 and host portion is lesser. Network increases, host will be reduces. Network size increases, host size is reduces. Okay. So here it is some conditions I will write, guys. To communicate between the devices, to communicate between the devices, they should be in same network. Means logical network also. Logical and of course physical. Physically they should be in same network. Logically also they should same network. Okay. Their network ID must be same. Network ID must be there. Okay. So here it is. What is the subnet mask? We know, guys, we know what is network portion, host portion, but what is this subnet mask? Network portion and host portion, we know it. Network subnet mask, system uses subnet mask. Okay, system use subnet mask to divide network portion and host portion. It is simple to understand, guys. Already I given one example, right? That is, here it is. This is one network. How I know it is one network? Like a all R16. This is compulsory. Network should be same. Host can be different. Network must be same. Host can be different. Now there are different things. For example, I have written 1507, 1508, 1403. Now it is different one. It's a different network. So these two will communicate. This won't communicate kind of stuff. Okay. Just for our understanding, divide network portion and host portions, and tells network ID of the IP address. So these are the default subnet mask. I have written here. This is default subnet mask. Subnetting. Subnetting. No. Don't confuse. No. This is up to here. Good. You understand this one? That is fantastic. Actually, I didn't expect you will tell answer also, and you got this point. That is enough. Okay. This is enough. Okay. So we'll meet you on a Friday, guys. Tomorrow is a holiday, Republic Day. So we'll meet you on a Friday. So okay.
Okay, sir. Thank you.
Thank you, guys.
Okay, sir. Okay, sir.
Yes, sir.
You're understanding this
Thank you,
part.
sir.
Thank you,
guys.
sir.
If you told more,